Alrighty, hello everyone. Welcome to the eighth episode of Observability Unplugged. Super excited to have you all here. My name is Kunal. I'm working as a DevRel engineer at Randoli, and I'm joined by Rajat, founder and CTO at Randoli. And today we are going to talk about agentic shift in observability, and specifically about how AI agents are shaping the way and changing the way teams are detecting, diagnosing, and responding to production failures today. And it's a topic that is very much happening right now, and people are talking about AI in every aspect of it. So we thought, why don't we talk about AI agents in terms of observability, right? And we have got a very special guest to talk about this, Benjamin, thank you so much for taking out your time for this. Would you like to introduce yourself and tell everyone a bit more about you?
Sure. Thanks for having me. Yeah, my name is Benjamin Bankford. I'm the co-founder of Rotational Labs. We build AI accountability tools focused mostly on computer vision and sort of large-scale operational AI. Our platform is part AI observability and monitoring, part evaluation and prototyping, and part sort of production grade, operational grade AI implementations.
Awesome. Yeah, I'm super excited to have you here. And thank you so much for taking out your time. So, before we start, a couple of housekeeping things for everyone who's joining in. I see a couple of folks joining in. So, I would recommend you can write a hi in the chat and let us know from where you are joining from. And because we are streaming live on YouTube and LinkedIn both, so if you would want to chat with us, this is a link to the YouTube live stream because LinkedIn sometimes lag, and I wouldn't want you to have that kind of an experience. So if you would want to chat with us and access all the links that we'll sending throughout the entire session, you can definitely head over to the YouTube live stream that you see right here. And feel free to ask all of your questions. We will be taking questions throughout the entire session. I'll be on the backstage noting down all your questions. You can share your experience and in the AI field and how you're using agentic AI and observability, right? So with that being said, Rajat, over to you.
All right, awesome. Let's get started. Once again, a big thank you to Benjamin for making time to, do this podcast with us. Really happy to have you. Awesome. All right. Okay, Benjamin. Let's start with some of the basics. We'll start with a couple of softball questions, and we can crank it up. No, I'm just joking, but I think clearing up some fundamentals would be helpful so we can bring everyone into the same page. Let's start with what agentic really means. Everyone's using the word agent or agentic. What truly makes a system agentic instead of just being AI assisted?
Wow. So if that's the softball question, I can't wait to see what the questions are coming in later. Yeah, everyone is using the word agentic, and I got to tell you, in my research, I studied cognition and metacognition, and so I have a pretty formal definition of the word agent, and that definition does not seem to be what's being used in sort of the AI marketing language that I'm seeing right now. But in order to be an agent, a computer system, not just a program, but a system has to be autonomous, and that autonomous nature needs to have goals. It needs to decide. It needs to be able to send and receive messages, perceive its environment, plan, evaluate plans, and then act. And so that definition of goal, decision, planning, reasoning, acting, and then if you're really doing well, the metacognitive loop of evaluating the cognition to see how well and create new goals. That's really what makes an agent an agent. And I think that LLMs are a very interesting tool to do agentic things. And certainly we could see things like tool calling or MCP servers as potentially being acts or actions for autonomous behavior. But I think that one of the really big things that's missing is specialization, right? Agents do something very particular. They're not just open-ended, broad, can do whatever types of things. Like, that's not how we hire human employees, right? We hire human employees for specific jobs. And so for a system to be agentic and not AI assisted, beyond that formal definition, I think that they need to have a very specific task that they are well trained, well tuned on, or set of tasks that they are, and that we as humans have trust that that agent can act, and that when it's unable to act, that it will escalate whatever it's in charge of in that very specific task.
Great start. That's a very that's a really great explanation. I loved it. See, I told you it's
Bringing in the computer science first thing here, right?
All right. So you use the word autonomy, and that's very important. In the context of an agentic system. With autonomy, there are other questions around it, right? Like, so when an agent has autonomy, that means it can plan and execute certain things. How should we structure this, right? Like, where should autonomy stop, and what decisions, should be delegated to an agent versus when it should be escalating? How do we think about that, right? I mean, because that's at the sort of the heart of it, right? Like, people are on one hand unwilling to trust something that can think for itself and make certain actions, especially in the context of a production system.
Mm-hmm.
How would you help us break this down and put some color to this?
Yeah, and that's a great question, and I think that technically, culturally, philosophically, we aren't prepared for autonomous non-human agents, right? We can't reason about them. I think the biggest trap that organizations and developers fall into is they treat AI systems like they are deterministic software systems, and they simply are not. They are probabilistic. I think that a lot of the conversation goes around confabulation and hallucination and those types of things. But even if something is not necessarily a confabulation, it will never be 100%. And that's by design, right? When we communicate with LLM systems, it's through natural language, not a formal language like a programming language. Natural language by design is ambiguous, right? It's meant to bridge communication gaps between two brains that have different experiences. It's not meant to communicate very specific instructions that need to be followed. That's what programming languages are for. So if we're going to delegate communication in natural language, then my biggest piece of advice was treat agents like humans. You have to. And so instead of saying, what do we need to do to trust an agent, or when do we delegate to an agent or not delegate to an agent? Like, let's look what we do in human systems, right? In human systems, it's about segregation of responsibility, right? You're responsible for this, you're responsible for this, and that limitation of responsibility gives you trust that you're not overloaded or you're not doing too many things. It's about training. The more proof that you have over time, either from education, experience, training, the more responsibility that you're willing to give a person. The same should be true of an agentic system. The less trust that you have in an agent, right? The more monitoring and the more attention you're paying to that person, the more supervision that you're given. That's why we see hierarchical human organizations, right? Where there's sort of management that gets, at the large scale management at the bottom, managing people who are actually executing tasks. So if you start thinking about it in that way, then, these ideas about autonomy and delegation become a little bit easier, I think, right? Because at once, if you're thinking about this like a human person, you can say, oh, well, they're doing way too much. A single agent should not be in charge of SRE for an entire data center, because we wouldn't let a single human do that, right? In terms of delegation of decisions, it's about how important is the decision, how much risk is there, and just in a human organization, the more risk, the more important the decision, the higher up the chain it goes, right? and we should do the same thing with how we view our agentic systems as well. The only difference between an AI agent and a human employee is the tireless ability that an agent has to do repetitive, boring, inconsistent tasks over and over and over again, possibly at scale, possibly at speed, but that's really the only difference. Otherwise, the same amount of cognition and trust and delegation we should put into our agents as we do into human agents.
I love that explanation and I love the analogy. I mean, thinking about agents just like humans, and certainly with humans, you still have the trust factor, right? So for some people, we trust more. Others, we'll have to do a little bit more supervision. But the other point that I got from this, you talked about the tireless factor, right? A human waking up at 2 a.m., certainly tired, sleepy, versus an agent that's, probably be able to operate at a slightly better capacity, may not have the same, I guess, depending on the context, the same experience, etc. But the fact that it's always alert, it's always running, and like you said, at scale, certainly can give an advantage. Amazing start. Now I have another question, and I see two questions from Manoj. Manoj, I'm going to take that on in a second. You did mention about probabilistic reasoning, right? What's just for the folks who don't have a background in AI, what's the difference between, say, probabilistic reasoning versus causal sort of reasoning? How and in most, I guess, when you talk about things like remediation of a production system, people are generally don't want random root causes or remediations being done, right? In that context, if you can give an example and explain the difference, that'll help folks who are not too familiar with the models.
Absolutely, yeah. So mathematically speaking, there are two types of reasoning. There's symbolic reasoning and there's probabilistic reasoning. I'm going to just say that for the most part, LLMs don't reason. So I know that there's a lot of marketing material coming out of Anthropic and OpenAI and Meta and others talking about reasoning and chain of thought. Those types of systems are actually augmentations onto the LLMs. It's not an LLM behavior in itself. All an LLM does is generate a sequence. And that sequence is usually language, right? That's all it does. You have to augment it with something else. Generally speaking, probabilistic reasoning is a little bit easier. So probabilistic reasoning in a mathematical form usually takes the form of like Bayesian networks, right? Where you sort of find the sort of maximum likelihood estimate of this is the probable cause based on these prior conditions that we've seen that propagates probabilities through these conditional probability networks. And then you get these sort of probable causes. Those, I mean, for a long time in computer science, we called those expert systems. That type of probabilistic reasoning has been used in medical diagnostics, car diagnostics, aerospace. There were simple versions of that in the Apollo space program. So like that probabilistic reasoning has been around for a very long time. The difference now is that we're doing it much, much bigger. And the thing with probabilistic reasoning is that probabilities can get very small. And you end up having, a float can only be so small, or float 64 can only be so small. And you end up with these very, very small numbers, especially when you have huge numbers of conditions. And so that's when these LLM techniques really start to come into play with deep learning and different types of things that they do. So that's the probabilistic reasoning. There is something that's categorically different, and that's symbolic reasoning. And I would like to see that symbolic reasoning, being used more. And I think that there's a lot of people experimenting with it now. I know Yanzi Kuhn, for example, is looking at world models that use ontological systems under the hood. An ontology is a form of symbology that can use graph processing to do that types of symbolic reasoning. Predicate, logic, modus ponens type inference. That's another form of symbolic reasoning. And lambda calculus is another form of symbolic reasoning. And in computer science, in the academic space, those are the tools that are generally used for reasoning. The disconnect, and I think what everyone's looking for right now, is how do we bring that symbolic reasoning into the agentic space, get it out of academia, get it into a space that's sufficiently large enough that we can deal with it at scale. And that's kind of the next frontier. And I think that once we hit that, we're going to see a fundamental change in the way that AI systems behave, and they'll become a lot more trustworthy. And like I said, there's some very smart people working on that problem right now, because reasoning is the clear gap in these AI systems. Even if you print out a chain of thought, you still just always have questions about, like, well, is that really the right thing? Because it's generated,
Great. That's again another, PhD level answer. That's a really great.
Sorry about that.
No. I meant that in a really good way. I think, a lot of folks would benefit from that answer. I loved it. And to your point, I think, correct me if I'm wrong, I'm just kind of, a little segue. Everyone was working on this symbolic branch, and nobody took, I guess, Jeff Hinton seriously when he was looking at the other branch. And in fact, it took people a while to accept that, and then suddenly that became more mainstream.
Right.
So just a little bit out of the topic, but why do you think that sort of happened? I was like, people were, for good reasons, obviously wasn't very trustworthy of the probabilistic approach, or didn't see promise, and now suddenly, that came into the spotlight and blew everything up. What are your thoughts on that?
Well, it's a matter of application, I think. The tools that we use in the commercial space, in the non-academic space, focus on very specific domain problem solving. I think that the big opening for LLM systems in particular was moving away from just generating data to chat, right? And that gave everyone the opportunity to interact with these systems in more of a meaningful way, to really start to devise applications that could be built up on top of it. And the ironic thing is, like, we're now moving away from chat. Like, chat got us in the door, but now it's like, okay, well, we actually wanted to generate JSON, right? Or we wanted to process these unstructured documents and generate a structured representation for our application. So we've moved away from chat to more domain specificity. But I think chat is really what opened the door, because, like I said at the earlier, culturally, technically, philosophically, we just aren't really ready for non-human autonomy, and so we kind of have to dip our toes in slowly. and chat was that slow toe dipping in to sort of open the door to keep moving forward with these types of technologies.
Awesome. Again, a great answer. Kunal, can we put Manoj's second question? I think Benjamin answered that to a large extent. If there's anything more to add here, it's a question from Manoj.
I think that an LLM is not the only part of an agentic infrastructure. So, I think that, people sort of assume that, Claude or Bandit or any of these, there's just a single LLM that's running. And that's not, in fact, true, right? It's actually probably several LLMs, some deep learning models, computer vision and multimodal models. There's probably some guardrails and deterministic structures in the back end. So I'm not saying that an LLM is not the right thing for an agent. I'm just saying that an agent requires more than just an LLM. just like a human needs more than a frontal cortex. So it might be a part of it. That said, I'm hoping that LLMs start getting smaller, not bigger.
So small language models that are specialized, right?
Yeah, that would be, I think that we're starting to approach the asymptote of parameters, like increasing parameters, increase more effect. I think GPT-5 was like the first signal of that more parameters isn't necessarily better. An LLM is really a brute force solution to a state smoothing problem, and better algorithms can absolutely do a better job with less energy and less compute. So, and if there are those other algorithms that are more deterministic that are used to augment LLMs or to augment a network of LLMs, that's probably what we are going to recognize as agents in the next 10 years.
That certainly, based on very little knowledge I have on the field, that's sort of what I am sort of reading into as well. And in fact, we're taking some concrete steps on how to figure out we can build a small language model around that. Also, your answer, it reminds me of that conversation we had a couple of weeks back where we talked about specifically Manoj's question, how do we take in, that probabilistic model or approach and then build some deterministic guardrails around it. And again, thanks for reinforcing that. So that's actually great, and explains how people can rein in some of the chaos and the hallucination around agents. And like you pointed out, the LLM is just one part of an agentic approach, and that's also another key piece of information. Awesome. I have one more sort of theoretical question before we kind of jump into the practical aspects. This is again, me trying to get some answers from you on some of the personal questions that I had as well, right? Is an agent fundamentally just a control loop with probabilistic reasoning layered on top of it? I know we've sort of talked about it a little bit, but maybe I should have asked this question a little bit early. But some people are explaining this as such. What are your thoughts on that?
It could be. It's not the way that I design agentic systems. The way that we design agentic systems is we create an agent that has a very specific domain, and that agent at its core is a set of tasks, a set of discrete tasks. We always give our agents names and descriptions to really specialize them. And we also give them business aligned objectives. So we say, like, these are sort of the key performance indicators for you as an agent. And all of that text and that input serves to guide the supervisory process in the agent. And then the agent itself is a set of tasks, right? So we define a task as, sort of a discrete input coming in, some sort of context processing, a prompt that's rendered on a per task basis, and then that prompt is sent along with tools like MCP servers to a single LLM, and then that LLM can decide if it wants to call those tools or not, go back and forth, and then produce some output, and that's a single loop of the task. And that's what the agent does. And what that means is that the agent's not based on a single LLM, because every task can have different LLMs. So if you have a task that can take advantage of an 8 billion parameter model, absolutely you should do that. If you have another task that requires something a little bit more robust, then use it for that task. But the agent is these collection of tasks. And then the agent has the tasks and all of the descriptions. So for any sort of incoming input, it can look at its set of tasks and say, okay, I want to use this task, I want to use this task, or it can combine those tasks into a workflow. And so when I frame it like that, the control loop is actually defined by us in terms of the tasks and the workflows, what MCP servers it has access to, what tools it has access to, what data sets it has access to, how the context processing goes. That is all deterministic, right? So you're asking if that's a deterministic control loop. It is. And then when you surround that by guardrails, you get a more robust system that can do very specialized work. But the key for us when we're building agents is if a piece of work comes in that none of those defined tasks fit with that piece of work, the agent must reject it. And I think that is the biggest problem with, the whole idea of probabilistic reasoning with a control loop, is that an LLM will not say, I don't know, or I'm unsure, or give you a confidence estimate, because all it's doing is generating text, right?
Yes.
Yeah. And so that, at the moment, until those sort of reasoning systems that we talked about before are actually really influencing LLM or AI behavior, you really have to put really strong controls on top of that control loop. And, hopefully my description of how we build agents, jives with what I was talking about before of what an agent is, very specialized, specific, domain engineered thing where the context is really richly, creatively defined and evaluated on an independent basis.
Awesome. I mean, again, I think this first, 25 minutes was really power packed with some very, very good explanations. Thank you for that. Sure. All right, let's switch tracks and try to talk about some of the concrete applications of this, especially in terms of observability, right? Just for more context, Benjamin also runs a startup, and like any startup founder, we sometimes have to wear multiple hats, and one of those hats happens to be doing DevOps, SRE work, right? And supporting your customers in production. So he's definitely qualified to talk about observability related issues by actually living through the pain and doing the work. So just so that I set the context for our audience where he's coming from, right? Now, we've spent a decade, looking through, like the telemetry, right? Right now, what we have is not a lack of telemetry, but sometimes more. But, that hasn't really, we have observability, through the roof, but it hasn't really materially reduced the cognitive overload on SREs during an incident, right? In fact, the surveys show that MTDR is rising as the systems get more complex. So it's definitely not a lack of telemetry, right? Do you care to add your thoughts on that? Let's start from there and then we'll build up. Yeah.
I mean, I absolutely feel that pain. And I would say not just in incident response, but even just in like deployment.
Deployments, yeah. And, development cycle, yes.
Development cycle, yeah. We, like I just mentioned, we're a team of 10, right? So we all have many hats, and one of my hats includes DevOps, and we're running clusters in North America, Europe, Asia. We've got sort of 5 Kubernetes clusters that are running. We have suites of applications that we're deploying for our customers, and as a small team, that's absolutely a nightmare. And you're absolutely right. Like everything we do has open telemetry built into it, and open observe, and we try to be sort of fully cloud native and cloud agnostic, and that's sort of another source of pain, is that we're across like multiple different clouds. So there's no easy button for us, certainly when it comes to observability. And it's just what I've noticed is that the definitions, there's just huge amounts of YAML, huge amounts of log, huge amounts of spans, lots of metrics. But the thing that went wrong, or the thing that you need to change, is one line, just a handful of characters somewhere in this very large system. And you're absolutely right. You have to funnel down all of this information to find that spot. And so to a certain extent, spans and tracing allow us to find threads and pull on them, but you also got to find that thread. And so I really understand why the MTTR is increasing as the amount of information that we have increases.
So you really set me up for my next question. That's about correlating the signals, right? Like if you find where to, if you end up, knowing where to look for, it becomes easier, but that's the harder part, right?
Mm-hmm.
So there's a lot of talk about, correlating between signals, and then there's also the reasoning about them, right? Like, so now let's put some of the, I guess, the background material we talked about, right, from a agentic perspective. Let's talk about correlating signals and reasoning, and sort of like what's the difference between them, and how can these tools help?
Yeah, absolutely. So one of the main analogies that I like to use with incident response in large-scale systems is immune systems. And there's actually a lot of computer science algorithms that use immune systems as a sort of metaphor or a model. So, I guess if you think about it, any normal operations will always usually follow the same patterns, right? So, you'll have these sort of web applications where there's like a login and a sequence of normal actions. And, those sequences of normal actions will cause backend actions and database queries. And, over time, you can sort of learn what's normal, right? What's normal behavior in the system. And that's not necessarily an LLM thing. There's a lot of different machine learning tools that can do this sort of autoimmune system. But by sort of building up this sort of idea of what's normal, that helps you do anomaly detection, right? Like what is out of the normal. And that anomaly detection really should be what we're doing for sort of the primary alerting, right? Like, something is out of the normal here, whether it's a bug or errors that are being thrown that weren't being thrown on the last deployment, or even if it's an attack of some sort. You're sort of creating that normal environment is sort of the pattern recognition part of what you're saying. Now, the reasoning comes after, right? Like,
go ahead. I'll let you finish. Let's go.
Yeah, just to finish up, the reasoning comes after. Like once you've decided that something's abnormal, right? The question is, okay, well, now what do we do with this alert? And I think that's where agentic systems come in, because a lot of times NOC operators get overloaded with alerts, right? And so a lot of their work is suppressing alerts in order to find the signal in the noise of alerts, right? Because, abnormal things they do happen, but that doesn't mean they're bad. So you got to suppress the signals. But if you put an agent into the middle and you don't suppress the signals and you have that reasoning component, that's where you might get some more effective SRE. So that's kind of where I would divide the line between an agentic approach to observability and just sort of that pattern recognition of what's normal behavior and what's not.
That again is a great insight in terms of using an agentic approach to look through all the signals and figure out which one's valuable, which one's not, because alert fatigue is a thing. And what often happens is sometimes when you suppress these alerts, you tend to miss sometimes the right signal as well, right? And so, yeah, this is actually, great insight. One other thing that I wanted to kind of touch upon. So we talked about identifying the normal. That's also easier said than done, because for some businesses, it's a little bit more predictable. For others, completely unpredictable. So for example, let's say a ride sharing app where, I'm understanding better about these different businesses as we onboard more customers, where they have some predictable patterns like, morning rush hour, evening rush hour, or some sort of a special occasion kind of happening. But then you suddenly also have a weather event or some sort of other event that is not very predictable. and then everything goes haywire. So generally the humans are able to understand. So if I say I'm an SRE, I'm looking at it, I can understand if a weather event is happening or something special happening, because I hear about it through the social channels or the weather app, whatever. So I am able to look into that and figure it out, right? In the context of an agent, or a machine learning model that's actually doing anomaly detection, it knows about the regular patterns, right? The morning rush hour, evening rush hour, and then you suddenly get hit with this. So these are things that are probably unavoidable, but curious to know your thoughts on that.
Well, yeah, I mean, I guess it's sort of an interesting question of does an SRE need to know why, right? Which is actually a fascinating question. I mean, the pattern recognition anomaly detection system will detect like there's something abnormal going on. In the case of a weather event, it won't necessarily come up with an explanation for that. In order to come up for an explanation, you need to feed in way more context.
Yes.
That is, it's actually one of the things that separates humans from agents, right? Like humans always have too much context. Agents can operate more efficiently because they have less context, right? So I think, when you start to ask why questions, those types of questions might be better delegated to a human rather than an agent. But that's not to say that you can't have an agent make suggestions about why something is happening, as long as you're feeding it correct context. But that should be not a live system, but maybe an augmentation system for the knock, as opposed to something that's running autonomously.
Awesome. Again, you kind of set me up for the next question, which is when to bring the human into the loop. We're not talking about completely replacing humans. We're talking about humans and agents working together. I love like the way you explain that humans have too much context, and that's why we are not as efficient as making decisions, and agents are more efficient because the context is small. So how would you like? I mean, again, that human in the loop is going to be very interesting. So when people are building agentic systems, they have to think about this. Where should we bring in the human? Where should we delegate it to them? Where should we get their input? Is that you want to, because you are in the, I guess, your day-to-day life, you're looking at this and advising customers. Can you give us a little bit more advice and some sort of, guardrails when, in designing agentic systems, keeping this in mind?
Yeah. There are a lot of tasks that I do in DevOps that I don't think I should be doing.
Yes.
Generally speaking, the line is, what is the risk, and what is the sort of beneficial impact, and sort of thinking about the trade-off between those two things. As an example, one of the papers that I wrote during my research was a self-augmenting system that used read and write patterns to automatically determine replication behavior across a globally distributed network using multi-armed bandits, right, to figure out where to place objects and how to maximize consistency while minimizing network traffic and storage load. And if that sounds boring to you, like that's exactly why you would use a multi-armed bandit to do that, right? Because that's not something humans shouldn't be doing that, right? Humans shouldn't be defining replication patterns in underlying systems. Going to Kubernetes, why do I have to decide what the resource requests and limits are, right? Like it feels like something should be looking at the usage patterns of all my pods and sort of allocating the resource and limits, correctly to my pods. That's not something I can come up with without some sort of analysis, and I would happily delegate that to an agent. We recently had sort of a spam attack on our registration system on our website, and it's like, yeah, no, if you shut that down, right, start collecting those IP addresses, that's absolutely something that I would allow an autonomous agent to like do, right? So there's sort of a lot of different things when you start looking like farther down in the system. It's like the really like low level things that absolutely that should be autonomous. It should be self-repairing. We're definitely headed that direction with some of the systems that are being designed and some of the newer distributed systems that are coming out of academia. and we'll absolutely get there. When the risk goes over the potential benefit, if the thing is doing things like changing passwords, or sending emails on your
Deleting
behalf,
things.
that's when you enter that gray area. And then I think there's obviously the really clear, like, humans should make decisions about this, things about why questions, right, or fundamental design changes, right. Those should be in the hands of human operators.
Well, thanks. That's a great answer. And, I think a couple of weeks we discussed this. I got some advice from you on that matter. When we experimented with sort of run books and that can be run automatically, this was more or less kind of like our thinking as well. Like, what's the risk factor? Is this something that we would even delegate to like a junior SRE or not, kind of thing, right? So that helps you inform what you can let an agent run automatically and which ones you want to prompt the human to execute those tasks, like whether it's a run book or some other sort of action. Great. We talked a little bit more about in the context of this conversation about pattern recognition and getting to sort of like the root cause analysis. And you said the agent can potentially recommend or suggest, right? And perhaps the human can then look at it and understand it. So to what extent the modern advances that we have that is sort of available to the masses, if let's say you're building a root cause analysis based on pattern recognition and other things, how would you think about where would you draw the line? How would you how do you design it? What are your thoughts? Again, sorry for all the ramping it up a little bit, but
No, yeah, it's absolutely a good question. The practice of root cause analysis is to find solutions that will prevent those problems from happening in the future. And I'm also just going to be a little bit honest here. It's also to find blame, right? Because whether we like it or not, there will probably be a lawsuit. There will probably be repercussions for an event that has a root cause analysis associated with it, and part of our system requires a little bit of blame there. So I think an autonomous system is very good at sifting through the observability mire to find those threads that you can start to pull on to find the root cause analysis. It's very good at finding patterns that can indicate systemic failure. I will say that in my experience, most root causes are very unique, very exotic in terms of a pattern recognition analysis, and that actually makes them even more well suited to an anomaly detection system, right? The more exotic it is, the easier it is to find. And then we also mentioned that potentially if you feed some extra context, an agent can come up with recommendations of why, but those recommendations should always be a ranked list. Before you move on to the decision of what was the root cause analysis, only the human operators have the sort of understanding about what are the consequences, what is the litigation responsibility, and only they can really decide what the root cause analysis is as a result. So that's kind of the line of actually saying, this is it, this is what happened. Because humans can be wrong and agents can be wrong, but only humans are liable, right? Yeah. Software systems are not liable until we give our legal system gives special recognition to an autonomous system as being liable. Then the humans are always going to be liable.
That is again another great insight. Absolutely right. At the end of the day, the humans are going to be responsible and sort of left holding the bag. There is an interesting question. If you can take a minute to answer from Manoj, here you go.
Yeah, there are a lot of different types of guardrails, both deterministic and non-deterministic. Yes, observed by another specialized agent, there are a lot of systems where it's basically a prompt that wraps another prompt, and you're asking the LLM, can you see a prompt injection attack in here? Can you see sensitive information here, named entity recognition in here? So those are one form of guardrails. I think that Llama Guard is one of the best examples of the open source world of that type of guardrail, the observed by another specialized agent by guardrail. But there are also deterministic guardrails. So for example, for sensitive information, named entity recognition, we use like Gliner on our input prompts to sort of figure out if there's anything in the prompt that could be sensitive information leak. There are fact-checking guardrails where you basically have to have citation references in the guardrails, and so you sort of check to make sure that they're guardrails, or even just like simple things like if you're expecting JSON generated output, like you match it to a JSON schema. Like frankly, that's a form of guardrail. that's very deterministic. So there's a lot of different guardrails. Guardrails tend to work like middleware, right? So you send the input through these middleware guardrails to make sure it gets through before it gets to the LLM. The LLM produces output, and then you send it through the middleware output guardrails again to make sure that everything's safe. Another very popular one is like content moderation. So for example, for like an image, if you want to make sure that it doesn't include something that's NSFW, then you would create a text description using, a model like Moonlight of the image, and then you would send that text description through like the Aegis classifier, which is the Aegis safety classifier, to determine if it contains like violence or sexual content or anything like that. So lots of different types of guardrails, both deterministic and non-deterministic, not necessarily agentic, sometimes agentic. But always they should be used.
Awesome. Yeah, that's actually a great piece of advice. And one of the things that we've noticed is that, and obviously we had some benefit of having this conversation some time back as well, is by validating and controlling the inputs and the outputs, that drastically improved the correctness or the reliability of the answer in the whole root cause process. So that's amazing. Thank you. All right, let's switch tracks a little bit, and I think again you kind of set us up for this final segment. We'll talk about reliability, risk, and governance. We have to do that. You already talked about my first question, though, which is about when an agent makes a recommendation, some action is taken, who's accountable? When it is wrong. Currently, it will always end up being the human or the organization, because the agent is not when you strictly speaking from a legal liability perspective. But how can we, setting aside the sort of like the whole legal aspect of it, when we build these systems, we have to almost build some sort of auditing capability, but also some way of providing the users who are going to be in the loop, or the humans in the loop, to have some mechanism to understand where this reasoning came from, or where these recommendations came from. And that's something that's important. Can you talk to us a little bit more about how, when we are building agentic systems, what should we do to increase the trust factor? And this is also extremely important in observability, because you sometimes have to make decisions under pressure. Your systems are crashing. The agent is giving you this recommendations and suggesting you run these remediations. How do we build that trust factor?
Yeah, well, we, in the systems that we build, governance is incredibly important. Auditing is actually one part, but like you said, explainability is the even bigger part of that. So in our systems, we always have an audit log of specifically the agentic action. So it's a little bit higher level than traces might be in an observability context. But specifically, what models being used, any seed, like random seeds, any temperature variables, like we want reproducibility from the audit logs. And then we save all context, all prompts, everything in and out of the LLM at all steps of our task workflows. And then any auxiliary data that comes along with it, like if you have like a chain of thought, or if you have like an explanation prompt guardrail, like explain why it came up with this, then we also save all of that information. And, you know, on some ways, like observability is something that you have to have and you have to record in order to take remedial action. And it generates a huge amount of data that then may need another agent to sort of look through all that data to explain things. But certainly for now, that's incredibly important to build up the trust. Because, you know, like I said, if you think about it like a human, right, you know, we give authority to humans based on levels of trust, and the same's got to be true for an agent, right? So if the agent is new, you should fundamentally not trust it, right? You should test it and evaluate it and make sure that in as many situations as you can think of, that it is doing what you expect it to do before you even give it a modicum of responsibility. Right. And you should try to refine it and specialize it to make it better at its job. It's exactly what we do with a human. Then you give it limited authority to do limited actions, right? And let it run for a long time. And as you gain more trust in the system, you can give it more authority to do more actions. So access control is incredibly important, you know, for read and write operations, because I mean, honestly, like what is an action or autonomous in an agentic system is fundamentally calling an API and executing a command, right? That's fundamentally what it is. So read operations are generally not dangerous. It's the write operations that we have to be primarily concerned with. So really restricting on the permission side what an agent can do and not do will prevent tripping hazards, right? And then the other part of that is, and when do you bring the human in the loop? Right. And again, it is a balancing act, because you don't want to just spam the user, like the operator, with, I need you to make a decision on X, I need you to make a decision on Y, right? Like the point of an agent is to alleviate that time and cognitive responsibility from the human so that they can do other things. But at the same time, it's just like a junior employee, right? Like the more junior you are, the more time you have to spend. The more senior you are, the less time you have to spend. So that also comes into the alerting and sort of the you know, create a human to make the decision, you know, to fundamentally take actions.
Amazing. I you know, again, a great sort of explanation, and you know, let's now jump into sort of like our final segment. Actually, sorry, I missed one great question on this. And given that you have a background in distributed systems, so this is going to resonate. I mean, they are already complex as it is. Now we're adding agentic layers on top of it. Are we introducing more failure modes? And we kind of briefly talked about it. Perhaps add a few thoughts here before we jump into our final segment.
I mean, simply said, yes, we are absolutely adding more failure modes.
Yeah.
We're adding more observability data, adding more information that we have to respond to. So yes, is a simple answer. We're adding more failure modes. And I mean, but again, it's the same as you get larger systems, you have to have larger organizing principles, and larger means more failure modes. So, and we're just at the beginning of this, right? You know, I think 2006 was kind of the first breakthrough with language models. Deep learning models have been around for a very long time. Since the 1930s, they've been used in air traffic control and long distance, and you know, but fundamentally, this is all very new. What's happening, and we don't even understand all of the failure modes quite yet. Yeah. So yeah, it's going to be an adventure, just like the beginning of the internet was an adventure. Right now, it's going to be an adventure with what we offload and with what we don't offload. But yeah, we're absolutely adding way more failure modes.
Great comment. Yet again, you set me up for the sort of like the final mini segment. we generally talk about the trends and the next 3 to 5 years. So here are two more not so softball questions. So the first one is we got to talk about the human impact of it, right? So going forward, do you see the role of an SRE evolving into supervising and managing a fleet of SRE agents who are like, or agents that are acting like junior SREs, or rather than just directly debugging systems? So right now, SREs have this, I guess, thankless task of sometimes getting their hands dirty, like going deeper into telemetry, figuring it out, and then figuring out the root causes, then the remediation. Will that transform into where they will have an army of agents doing the heavy lifting of doing the debugging and figuring out the remediations, and the job of the SRE is now about, hey, they've been the human in the loop to say, yep, let's do this, let's not do this, and being more of a, I guess, a human supervisor for these agents.
I mean, I do, and I hope so. And not just SREs. I'm hoping that a lot of jobs become more like what you just described.
I try to limit the candidates, but yes.
I know you can't comment on those. I think that the SRE thing will happen sooner than, say, manufacturing. Right?
Correct.
Although, my father-in-law worked for, a big manufacturer, and he supervised robots. So it's like that's been happening for a long time already anyway. But yeah, I think the SRE thing, and I think developers are more prone to pick up these agentic tools more quickly because, it's sort of in our tech space. But, I would certainly like to see agents helping out in legal and medical situations and sort of augmenting any decision-making behavior like an SRE. That's what I'm hoping to see. So, SREs, information technology is fundamentally going to underpin the economy. SREs need to be more effective at their work, not more overburdened. So yes, they should be managing an army of agents. I will say that the current algorithmic stack is not well suited to that. So I am not saying that this is a tomorrow thing or a today thing. I'm not saying this is a next year thing, right? We already talked about some of the developments like world models from Jan LeCun, different types of reasoning models that, different types of planning and execution that need to happen in the agentic space before we can get to that point. But hopefully within 5-10 years, that is what the experience of an SRE will look like, as well as an X-ray technician, right? And, a postal office worker. And really, a lot of people should be feeling like in 10 years that will be their job.
So final question. And again, slightly, I guess, on the controversial side. So right now, teams are responsible for MTTR. A lot of organizations that are, very much into this incident management culture religiously track MTTR, and the teams are responsible for it. In fact, some managers' compensation is tied to maintaining those SLAs and maintaining those MTTR numbers. When we shift to this, that what we talked about, will MTTR become more of a measurable property of the system itself or some sort of vendor that they purchase rather than the team operating it? Or it'll be a shared responsibility? Who are you going to blame in the, when something happens?
Yeah, it's a very interesting question. I mean, MTTR should be a property of the system. I think it's a human instinct to make it a measurement, like a key performance indicator, because there is a limit, right? Like at some point, MTTR is so quick that it's meaningless if it gets quicker, right? So I really do think it should become a property of the system because it'll be because it's so fast that it doesn't matter, right?
Yes. Yes, exactly. Thanks. I mean, that's what I was thinking too, because we will probably get to that point where it is going to be very quick, that it is less meaningful than what it is today, right?
Yeah, exactly. You measure it in hours, it matters, and humans will evaluate each other. You measure it in minutes, maybe not so much.
There you go. Awesome. That's a great sort of ending to our segment. Benjamin, it's been a real pleasure speaking with you, and I think this is one of the best segments that we've had. Lots of great pieces of wisdom for us, and lots of good explanations. And I hope the audience also found this very useful. And thanks again, Kunal. You wanna get some final thoughts from Benjamin, and we can close it out. And for a change, today we are on time too.
Oh yes, I was just making a couple of notes on the side as well, because there were a lot of interesting things you shared, Benjamin. First of all, I just loved all the points that you shared, and I feel that this particular topic is interesting because this whole discussion of AI agents and using AI in DevOps and observability is relatively new, right? And because it's new, we are seeing a lot more interesting use cases, and we are seeing a lot more interesting questions. It's sort of like how things started when Kubernetes was introduced, right? People are experimenting with it, asking different questions, asking different use cases. So I think that is why this whole topic is pretty interesting, and definitely I believe that you both covered a lot of interesting stuff. But yeah, do you have any closing remarks for anyone who's watching till this particular point?
Sure. I mean, I just want to say thank you guys for having me. I really enjoyed the questions. I hope it wasn't too academic, but
No, not at all. Not at all.
I do really enjoy talking about the philosophy behind these things, not just the practical applications. I appreciate you guys giving me the chance to do it. If anyone's interested in building agentic systems, we'd love to come visit us at rotational.ai, and all of the things that we talked about, the principles. That's how we build things, and that's how our platform builds things as well. And really enjoyed watching you guys build those types of things into your platform as well, with the runbooks and that kind of stuff.
Yeah, thank you, and thanks for being an advisor, and then also like the knowledge you shared today. Really great. And then guys, yeah, please check out rotational.ai, Benjamin's startup. They're doing some really cool things, and if you haven't already, follow him on LinkedIn. He regularly shares his opinions on the topic, and I for one always keep an eye out for his posts. All right.
Appreciate it.
Yeah, definitely. And if anyone's watching the recording right now, because I see a lot of people watch the recording, if you have any questions that you would want to ask to Benjamin, feel free to drop them in the comments, and we'll make sure that Benjamin answers those questions. We'll catch him.
Absolutely.
But yeah, appreciate it, Benjamin, and appreciate it, Rajat. Thank you so much, everyone, for watching, and we'll see you in the next one. Bye bye.
Thank you very much.
See you guys. Bye bye.